Good morning, everyone. I'm Mitsuhiro Omata. I work at Obayashi Corporation as the Deputy Project Director. I'm a little bit nervous because I have to speak after two amazing presentations. I'd like to talk about BIM from the site position, site perspective. It's my great pleasure to be here today. I'll talk about digital transformation in construction, digital twin site management as a Kawakami Dam project. I'll go over the introduction of ourselves, the challenge of our industry, and what was done in the Kawakami Dam project. Especially, a lot of research and development was done on the drone deployment, so I'll cover that. And finally, wrap up with the next steps and summary. Let me introduce myself. After I joined Obayashi Corporation in 2000, I have a long experience in civil engineering, especially in the field of building dams. Today, I'm going to talk about the most recent project in Kawakami Dam construction. Look at the bottom of the slide. There are my hobbies: skiing, bouldering, and video editing. This is a snapshot of the Obayashi Group. Obayashi Corporation was founded in 1892, meaning that we are 131 years old so far. It's a kind of long survivor in this field. There are 125 group companies doing business among 16 countries with about 50,000 employees. Our annual net sales revenue reached $15.8 billion, representing the highest rank for the past 6 consecutive years from the revenue point of view. The outline of Kawakami Dam is as described in the slide, and the project is to build a medium-sized gravity concrete dam. This is the picture during construction. In this project, because of the short construction period, we automated a lot of processes in our project, which I'll cover later. So let's move on to the challenges in the construction industry. As Elon Musk worried in one of his tweets, Japan is entering society with a declining population. Additionally, a decrease in the number of dam projects is also leading to a shortage of experienced dam engineers. So it is important to efficiently manage the vast construction site area with limited number of engineers. To achieve that and improve the productivity of the construction, we transformed several manual processes into digital. The following are the efforts done in this project for digital transformation. We built 3 digital twins from the data that was provided by the client. The first is the construction information modeling. Is similar to BIM and serves as an accurate blueprint for construction. The second is the data stock of the construction data. It collects and stores the as-is conditions and will be handed over to our client after completion. The third will be the cyber physical systems, CPS, that analyze and displays information collected by sensors from the real world in a cyberspace. Here, it is possible to visualize the movement of the construction equipment as well. For example, you can see 2 cranes are operating automatically, which was one achievement of this project. What you are seeing is the CPS, and the small windows are what you see through the camera. 2 things are essential to displaying this dynamic data. One is the BIM, and the other is the static point cloud data that serves as the background. And these point cloud data should be updated promptly, or the digital twin cannot remain accurate. To do that, we used drones. For utilizing drones in construction site, there was a change in the regulation. Before that, we could only operate the drone under the operator's visual site. However, the revisions to the civil aeronautics law have made it possible to fly level 3 and 4, which are flights beyond the visual line of sight, VBROS. Since it does not require visual observation anymore, VBROS flights such as level 3 flight have the potential to increase the productivity of the site management. Taking this opportunity, we developed the drone and the system so that it can be flown remotely, as shown in the photo on the right. I'll talk about what and how we developed drones. First, please take a look at this video.
In this demonstration experiment, we successfully carried out Level 3 flight. Level 3 flight means beyond visual line of sight flight in uninhabited areas. We divided the demonstration range into 4 areas and flew our drone. A web camera was used to monitor the parts passing over the active road. A Starlink base station provided by KDDI is installed in the area with poor connection. Covering the area with poor connection enabled the flight with regular LTE communication. The drone flew while switching base stations by a technique called handover, and also flew outside the drone's remote controller area. In this demonstration experiment, the systems of the 2 companies worked seamlessly together. Cooperation with earthquake detection, elimination of weak electric field area, Solatana for weather forecast. All of these technologies enabled the Level 3 flight. After taking the images, it will work with the AI Image Judgment System (NCPS). Not just developing individual technologies, we also work on linking and connecting different systems.
The purpose of this development was to improve the productivity of construction management with this technology. Specifically, we built a drone system that automatically performs 4 tasks: patrols, inspections, measurements, and abnormality detection. This information was linked to the cyber physical system that centrally manage the job site. We took a partnership with a company called KDDI Smart Drone. Each company brought in their own strengths for effective collaboration. One strength of Obayashi is the overall coordination of the development. The following is an overall picture of that development. The orange frame shows the role of Obayashi, and the light blue frame shows the role of KDDI Smart Drone. The main focus of the development is the Level 3 flight conducted by the KDDI and Obayashi. Since this site is in the mountains and had poor connectivity, we are also reinforcing the radio wave. The data acquired by the drone is displayed by the AI image judgment system and the CPS constructed by Obayashi Corporation. In addition, an emergency flight function has been developed in the event of an earthquake. The two companies' systems are highly linked, and flight instruction can be given from Obayashi's CPS to the drone flight system. KDDI Smart Drone's capability is operating and communicating with a variety of drones. The drone and drone pod used in this project is made in Taiwan and can perform automatic takeoff and landing and automatic charging. Another capability of our partner was to support the poor connectivity area. We installed a Starlink base station from SpaceX so that we can operate the drone flight even in the mountains. In order to fly over the entire dam project area, the technique to switch the base station of the drone between existing LT base station and the Starlink base station was essential. The expertise of KDDI Smart Drone's parent company that operates telecommunications was utilized here. These dots represent the communication period and the connectivity of the drone and our system. As you can see, after the installation of Starlink, the communication has been stabilized and communication breaks have been eliminated. From now on, I'll show the result of the drone flight. The area marked in yellow is the flight area. The drone pod was placed in the red circle, and the flight area was divided into 4 locations. All of them were level 3 flight, so the drone flew autonomously without any human assistance. This slide indicates the flight monitor and the management system that we developed. LTE communication enables real-time monitoring of the drone's attitude, altitude, and speed, and the deviation between the planned route and the actual position of the drone. These are 4 examples of the flight path. The top 2 are for measurement purposes, and the bottom 2 are reservoir flight for inspection and monitoring purposes. For measurement purposes, we developed an AI image judgment system. Using machine learning, the system automatically marked digits and other areas to determine the progress of the site. The displayed image shows a comparison of analyzed data on the status of dam topside maintenance work. Comparing the images, the line of the detection results are extended, confirming the progress. Next, I'll explain the CPS display of point cloud system. The point cloud data that forms the basis of the CPS is uploaded onto the KDDI cloud. We have developed a system that easily imports this data into the Obayashi system and displays it. Path data comparison can also be performed. The screen works like this. In addition, we have developed a function to cut any area on this system in a polygonal shape and calculate the amount of change in soil volume. Heat map display and calculation of the difference in the quantities are also available. In addition, arbitrary cross-sectional displays can be easily performed. We also conducted a flight for abnormality detection of the reservoir, which is more than 5-kilometer round trip. These acquired photos were uploaded to the cloud immediately after the flight, and time series comparison can be made on the cloud. Finally, I'll explain the emergency flight function in the event of an earthquake. Information on the occurrence of an earthquake is sent from Obayashi's GPS to the drone side system, and an emergency flight can be automatically booked. At the same time, a notification message is sent to the chat application. Here, I'll introduce 3 AI image evaluations.
Kawakami Dam construction project has been working on AI-based productivity improvement initiatives for some time now. Here, I will introduce 3 of them. Please see the video. The first initiative is management of excavation machines with AI. We train the AI model to analyze the productivity of the machines by identifying the type and movement with bounding boxes. The second initiative is management of the progress of concrete pouring. Here, we develop the AI to segment and identify the poured area. Additionally, this segmentation identified the human and machine movements as well. The third initiative is the autonomous operation of tower crane, as we saw previously together. This attempt involved 7,000 hours of AI training.
For the next steps, I'll name 3. First, we aim to achieve stable flight under LTE communication environment for level 4 out-of-sight flight without assistance in a human-occupied area. Second, we will promote the operation of multiple drones. Third, we will develop more use cases with the CPS. For the overall summary for today's talk, Kawakami Dam has been challenging new technologies through field-oriented development. We have to aiming to improve the productivity of on-site management through technologies. And the people on-site who are at the forefront of construction need to connect the dots and lead to the development of the technology. That's all for today. And now I'll open up to any questions. But I'm improving my English skill, so my coworker Marcel helped me. Thank you.